Today I'm going to be going over your Unit 9 Part 2 test review. So our first question here, suppose that the function f is represented by this power series. This power series is an infinite geometric series. Okay, its common ratio is x over 4 if we look at what we're multiplying to get from term to term there. So for our interval of convergence, we put the common ratio between -1 and 1 and solve for x. So we'll multiply all of this by 4. So when x is between -4 and 4, this series converges. To name the function, okay, the function is going to be a1 over 1 minus r. So in this case, our a1 is 1 over 1 minus our common ratio. Find f prime and f double prime. So remember that the general form of a Maclaurin series is this is f of 0, this is f prime of 0 times 1. So f prime of 0 is going to be 1/4. For the second derivative, we know that the second derivative at 0 over 2 factorial is going to equal the coefficient of the squared term. So that's going to equal 1 over 16, which means our second derivative is going to be 2 over 16, or 1/8. Okay, then describe what's happening to the graph based on that. Well, if the first derivative is positive, our graph is increasing. And if our second derivative is positive, our graph is concave up. All right, these are the big four for our Taylor series. E to the x is all of them. So this is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. That's 4 terms, plus dot, dot, dot. Plus our general term is x to the n over n factorial, and then we do need the plus dot 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 afterwards because this is infinite. This one is our geometric with a a1 of 1 and a common ratio of x. So this will be 1 plus x squared plus x cubed plus x to the n plus dot dot dot. Cosine is our even function. So this is going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. The general term here, -1 to the n, x to the 2n over 2n factorial. Okay, sine is our odd function. So this is going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Our general term is going to be -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial plus dot dot dot. Now we're going to kind of work backwards. So it says find the sum of the series. So what we're going to do, notice there's no x's in any of these. We're going to match the function with the appropriate general term and then figure out what the x is. So this first one is going to be our e to the x, where our x is 1. So this is going to be e to the 1. Here, this is going to be the same as -2/3 to the n. Well, that is our 1 over 1 minus x, where my x is -2/3. So this is going to be 1 over 1 plus 2/3. So that's 1 over 5/3, which is going to be 3/5. Next one is the odd function, so that's going to be sine. So this is sine of pi over 3, which is going to equal root 3 over 2. This one's our even, so that's cosine of 2 pi over 3, which is going to be a negative 1/2. So we're going to find the coefficient of x to the fourth in a Taylor series for x sine x around x equals 0. So sine of x is our odds. So x minus x cubed over 3 factorial and so on. I don't need any more because I'm looking for x sine x. So that'll be x squared minus x to the fourth over 3 factorial. So our coefficient is 1 over 3 factorial, which is going to be 1/6. Okay, next up, we're going to take this derivative, and it's just going to be the power rule. So the negative 1 to the n goes along, and then we do the power rule on this. So we'll multiply down the exponent, and then subtract 1 from the exponent. Okay, these will cancel. So this is now negative 1 to the n, x to the 2n. Okay, a function f has a Maclaurin series, x to the fourth over 2 factorial plus x to the fifth over 3 factorial plus x to the sixth over 4 factorial and so on. So which of these is the answer? Well, the first thing to look at is we're not alternating between, the terms aren't alternating. We have all of the powers. I mean, we're starting at 4, but it's not going 4, 6, 8. It's going 4, 5, 6, and we have all of these. So my base function is going to be e to the x, not a trig function. So we just need to figure out which of these two is going to match. So looking at this, the difference is whether we're multiplying by x squared or we're doing a substitution with x squared. So if I have e to the x, which is 1 plus x squared over 2 factorial plus x to the fourth, x cubed over 3 factorial plus x to the fourth over 4 factorial, and so on. And I multiplied everything. Actually, let's do this one first, and I'll show you why. If I replaced x squared, we're going to have 1 plus x squared plus x to the fourth over 2 factorial, looking promising, plus x to the sixth over 3 factorial. Okay, not x to the fifth. So that is not our answer. So if we multiply here, just to confirm, instead of substituting, that's going to give me, we're multiplying, so x squared plus x cubed plus x to the fourth over 2 factorial plus x to the fifth over 3 factorial, and so on. So this one is our correct answer, because what we do is subtract that and subtract, and then we'd start here. Okay, question 8 has actually been eliminated from the test. It's good information, so you might try going through it, but for the purpose of the video, I'm going to skip it. Okay, draw a sketch of the graph of a function that can be approximated by the polynomial -1 plus 2x minus 3x squared. So what information is here? Well, this tells me that f of 0 is -1. Since the second derivative, or the first derivative, is positive, which means our graph is going to be increasing. And then the second derivative is going to be less than 0, so it's negative, so it's going to be concave down. So I'm going to draw a graph, -1, that goes through -1, that is increasing, but concave down. Okay, so if f of x is 1 over 1 minus x is x to the n squared, so just or x to the n, so just our basic power function, write this one in sigma notation. Well, in sigma notation, there's a couple different ways to do it, but a geometric series can be rewritten as a1 r to the n. Well, my a1 in this case is going to be 2x. So I'm going to have 2x times my common ratio is going to be a negative x cubed. So I'm just going to put a negative x cubed in parentheses there to the n. So this is good, or you could simplify it if you want to, but I'm going to leave it just like that. Okay, so we're going to write the power series for natural log of x minus 1 around the point x equals 0. We're going to find the first 4 non-zero terms and the general term. You can do this using integrals, or we can do this just using the rules for a Taylor series or Maclaurin series. So f of x is natural log x minus 1. So f of 0, we're going to have, sorry, f of 0 will be 0 minus 1, so that'll be the natural log of a positive 1 for the absolute value, which is 0. Then we're going to take the derivative. So that's going to be 1 over x minus 1. If we plug in a 0 here, we're going to get negative 1. The second derivative is going to be negative 1 over x minus 1 squared. So if I plug 0 into this one, this is going to be a positive 1, but then that's going to make it negative. The third derivative here is going to be, this is going to be the same as x minus 1 to the negative 2. So this will be a positive 2 over x minus 1 cubed. And if it helps you to write it out as the power, feel free to do that. So if I plug in 0 here, this will be 2 over a negative 1, or a negative 2. And then we need 4 terms, so I need one more. So this is going to be 2 times x minus 1 to the negative 3, so we'll have a negative 6 over x minus 1 to the 4th. So we're going to have negative 6 over a positive 1, so negative 6. So let's put this together. So f of 0 is 0, so that doesn't have a term. So we're going to have a negative x minus x squared over 2 factorial plus, minus again, 2 over 2x cubed over 3 factorial, and then another minus 6x to the 4th over 4 factorial. Well, these ones were obtained, we multiplied the 2 times the 3, the next one would multiply the 6 times the 4. So these are actually factorials. So I can reduce this, and that's going to help me with the general term. So this is going to be x squared over 2. This would be 6, so 2 over 6 reduces to 1/3. 6 over 24 reduces to 1/4. So my general term here is going to be negative x to the n over n factorial, or negative x to the n plus 1 over n plus 1, not factorial anymore, sorry. Either one works. So now we're going to write the Taylor series for 1 over x minus 1, so similar to the last one we did, but our center is now 2. So my function is 1 over x minus 1, so f of 2 is going to be 1 over 1, which is 1. We'll take this one's derivative, which is going to be a negative 1 over x minus 1 squared. So f prime of 2 is going to be negative 1 over 1, so a negative 1. Our second derivative, again, treat this like a negative 2, so this is going to be a positive 2 over x minus 1 cubed. So our second derivative at 2 is going to be 2, and we need one more to get to 4. So this is going to be a negative 6 over x minus 1 to the 4th, evaluated at 2 is going to give me a negative 6. So our function is going to be 1 minus x plus 2x squared over 2 factorial minus 6x cubed over 3 factorial. Oh, apologies. Forgot my center. So this is going to be 1 minus x minus 2 plus 2 times x minus 2 squared over 2 factorial minus 6x minus 2 cubed over 3 factorial, and so on. So I'm going to simplify this in order to write the general term, because these 2 and 2, 3, or 6 and 6 will cancel. So this is 1 minus x minus 2 plus x minus 2 squared minus x minus 2 cubed. So my general term is going to be a negative 1 to the n, x minus 2 to the n, plus dot, dot, dot. Okay, looking at these next two, they are asking for the interval and radius of convergent, and these two series look super, super similar. The difference is this one has an n in the denominator, this one doesn't. This one is the series, if I combine these, x plus 1 over 4 to the n, making it an infinite geometric series, which makes our interval and radius fairly simple. Okay, the common ratio here is going to be x plus 1 over 4. And in order for x plus 1 over 4 to converge, it needs to be between negative 1 and 1. So multiply by 4, and then subtract 1. Okay, so we've got our interval here. For the radius, this is negative 5, this is 3. Halfway in between these would be negative 1, so the radius here is 4. And we could get that from here too. Okay, this one, however, is not infinite geometric, so we're going to need to do the ratio test for absolute convergence. So we're going to do the limit as n goes to infinity of the nth plus 1 term, which is going to be x plus 1 to the n plus 1, over n plus 1 times 4 to the n plus 1, all over x plus 1 to the n over n 4 to the n. So we've done these enough to know what's going to happen. We're going to have x plus 1 to the n times x plus 1 over n plus 1, 4 to the n times 4, times n, 4 to the n, over x plus 1 to the n. Okay, and then we get to cross stuff off. So the x plus 1 to the n cancels. The 4 to the n cancels. And we're going to pull the x plus 1 out. So we're going to have the absolute value of x plus 1 times the limit as n goes to infinity of what's left. Well, on the top I have an n. On the bottom I have 4n times n minus n plus 1, so 4n plus 4. So that limit is 1/4, and we need that to be less than 1. So we need negative 1 to be less than absolute value of x plus, not the absolute value, x plus 1 times 1/4 is less than 1, multiply by 4, and subtract 1. Okay, so this is our range. So my radius is still going to be 4. Okay, for the interval, because this isn't geometric, we need to test the endpoints. Okay, so we're going to test -5. So when x is equal to -5, my series, when I plug in -5 in here, is going to be a -4. Okay, well the -4 to the n over 4 to the n is just the same as -1 to the n. So this is alternating harmonic. So this converges. We can always say that. So the 5 is included. What about the 3? Okay, well we plug that in. That's going to be now 4. Well, that's just going to be 1. So this is 1 over n, which is our plain old regular harmonic, which always diverges. So 3 is not included. So this is my interval. -5 is included, the 3 is not. Okay, this question and this question have been eliminated from the test, so we're going to move on. All right, so for our next one, let f of x be the function that has derivatives at all orders, and then we're given f of 0 is 5, f prime of 0 is -3, f double prime of 0 is 8, triple prime is 24. So we're going to write the third degree polynomial. So P3 is going to equal 5 minus 3x plus 8x squared over 2 factorial plus 24x cubed over 3 factorial. Then we're going to use that to approximate 0.4. So all we're going to do here is plug in 0.4, and we're going to leave it. You have a calculator, you could type it in, but this is a perfectly acceptable answer. Right? Now we're going to take the derivative. Derivative of 5 is 0, so we're going to have -3 plus 16x over 2 factorial plus, if you multiply that, or we're going to say 3 times 24x squared. Okay, that is going to be 72, but I don't really care. So plug in 0.4, so -3 plus 16 times 0.4 over 2 plus 3 times 24 times 0.4 squared over 3 factorial. All right, we got another Taylor series. And this is a pretty classic question from the Taylor series given specific values. So f of 0 is going to be 2. For the second one, we know that the second derivative evaluated at 0 divided by 2 factorial resulted in 8 over 9. So then we'll just solve that by multiplying by 2. So that's going to be 16 ninths. Okay, can the exact value of f of 2 be determined? No. The only thing that we can determine is anything about 0. The center is 0, not 2. So we have no information about 2. Okay, now we're going to integrate. We want the third order. So this is going to be the integral from 0 to x of f of t. So we're going to take this, I'm going to have 2 plus 8, and you'll notice this is actually different than the printed version. This is going to match what you have on your test. So if I want a third order and I'm integrating, I can stop at the 2. So we're going to integrate here. We're going to have 2t plus 8 over 27t cubed plus dot 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 evaluated from 0 to x. Actually, I guess we don't need the dot 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 because we're just doing a third order. But 2x plus 8 27ths x cubed, and then evaluated at 0 is 0. So there is our third degree polynomial. The last part of this question says, does the graph have a local min, max, or neither at x equals 0? Well, that is going to be determined by the first and second derivatives. There is no linear term here. So f prime of 0 equals 0, which means there is a critical point. We move to the second derivative. The second derivative at 0 is positive. It's positive. We found it to be 16/9, but we care that it's positive, which means it's concave up. So if my graph is concave up and the slope is 0 by the second derivative test, this is going to be a local minimum. And our justification is these two pieces of information here. Okay, what is the approximation of cosine of 2 obtained using the 6th degree polynomial? So cosine is our evens. So that's going to be 1 minus x squared over 2 factorial, so 2 squared over 2 factorial, plus 2 to the 4th over 4 factorial, minus 2 to the 6th over 6 factorial. Now you can leave it just like this. I will go ahead and give you the value, but you don't need to do that part. Okay, what is the error bound? Okay, this is an alternating series, so we're going to use the alternating series error bound. Okay, which is simply the absolute value of the next term. Well, the next term would be 8, so my error is going to be less than 2 to the 8th over 8 factorial, which again, you can leave it just like that, just for numeracy's sake though. 635. My reason, this is my reason. It's an alternating series, so I can use the alternating series bound. Okay, so we're going to write the first 4 non-zero terms of cosine 2x. So we're going to plug 2x in for x. So this is going to be 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial, our general term. Basically, I'm going to take this and plug in a 2x there. Plus dot dot dot. Right, now we're going to do the same thing with an x squared. Cosine x squared is equal to 1 minus x squared squared plus x squared to the 4th minus x squared to the 6th and our general term. Okay, it says use your answer in part D to find this limit, okay, where f of x is going to be this series here. So what is it we have? So we're looking at the limit as x goes to 0 of 1 minus x to the fourth over 2 factorial minus f of x. So that's going to be 1 minus x to the fourth over 2 factorial plus x to the 8th over 4 factorial minus x to the 12th over 6 factorial over x to the 8th. All right, so what do we have here? The 1 minus 1 is going to go away, and a negative x squared minus a negative x to the 4th over 2 goes away. So we have x to the 8th over 4 factorial minus x to the 12th over 6 factorial, and so on, divided by x to the 8th. All right, so now we have limit as x goes to 0. This divided by x to the 8th is just going to be 1 over 4 factorial minus x to the 4th over 6 factorial, and so on. So everything after this is going to contain an x. So as we go to 0, that's going to go away. So we're left with 1 over 4 factorial, which is 1 over 24. Okay, so if g prime equals cosine x squared, find the coefficient for x to the 9th in the series for g of x. So we're going to look at the integral from 0 to x of g of t, which is going to be 1 minus t to the 4th over 2 factorial plus t to the 8th over 4 factorial. And integrate, so that's going to be t minus t to the 5th over 5 times 2 factorial plus t to the 9th over 9 times 4 factorial. Okay, well this is my coefficient. I mean, we're evaluating this from 0 to x, but what I'm interested in is the 1 over 9 times 4 factorial, which is going to be 1 over 9 times 24, which is 1 over 216. Okay, last part of this, find the coefficient of x to the 6th for the Taylor series cosine squared x. There's two options here. Number one is to use the double angle substitution, or you can treat this as cosine of x times cosine of x. You'll get the same thing either way. I am going to do the chart, okay, and that's up to you. Otherwise, you rewrite this using 1/2 plus 1/2 cosine 2x, and in it, write out that series. Okay, but I'm going to go ahead and make a chart. This is going to be cosine. This is going to be cosine. So I'm going to have 1 negative x squared over 2 positive x to the 4th over 24 and negative x to the 6th over 6 factorial. Okay, I can stop there because I'm looking for the 6th, and then the same one's here. 1 negative x squared over 2. I guess I can leave it as 4 factorial. X to the 4th over 4 factorial, and negative x to the 6th over 6 factorial. All right. So I only care about the ones that are going to result in a degree 6. So that's going to be if I multiply a 1 times a 6. So this is going to be negative x to the 6th over 6 factorial. It'll happen if I multiply a 2 and a 4 together. So this will be a negative x to the 6th over 2 times 4 factorial. Here and here gives me the same thing, negative x to the 6th over 2 times 4 factorial. and then negative x to the 6th over 6 factorial. Okay, well, pulling those all out, I've got an x to the 6th times negative 1 over 6 factorial minus 1 over 2 times 4 factorial minus 1 over 2 times 4 factorial minus 1 over 6 factorial. So my coefficient is going to be, I've got 2 of those, so negative 2 over 6 factorial and 2 over 2 times 4 factorial. And you can go further if you want to, but I'm just going to stop there. All right, so now we have a recursive formula. So we're looking at the power series an x to the n, where an's are going to be generated with this, with a0 being 1. Okay, a1, according to the recursion formula, is going to be 3 over 1 times a0, which is 1. So we get 3. A2 is going to be 3 over 2 times the previous term, 3. So we get 9 over 2. The next one is going to be 3 over 3 times 9 over 2, which is going to be 27 over 6. But I want to look at these numbers. Okay, 1, 3, 9, 27, those are powers of 3. So when we rewrite this as 3 squared and 3 cubed. And then the 2, 6, the next one would be 24, is going to be factorials. So this is 3 factorial. So my series my terms are going to be generated by this an that we just found. So we're going to have x plus 3x minus 3 squared x squared over 2 factorial plus 3 cubed x cubed over 3 factorial. So this is going to be 3 to the n x to the n over n factorial. Okay, which should seem similar. I could rewrite this as 3x to the n over n factorial. And this is our formula for our series for e. But instead of x to the n, we have 3x to the n. So this is saying write it in terms of a familiar function. So f of x is e to the x, but instead of x, 3x. And then we're going to use that to find f prime of 1. So f prime of x is going to equal 3e to the 3x, which means f prime of 1 is going to be 3e to the 3. Okay, my next question says, and these are all Lagrange error bound, let f of x be a Taylor function that converges for all x if the absolute value of the nth derivative is less than 4, and fn is the nth derivative of x, what is the error bound approximation approximating 2.3 by the series P4 2.3 if the series is centered at x equals 0. Okay, the error in general for the Lagrange error bound is less than m x minus a, what is the absolute value of x minus a to the n plus 1 over n plus 1 factorial, where m is the maximum value of the derivative. So for our cases, the error bound, my m is 4, my x is 2.3, a is the center, which is 2, and then if this is a 4th degree polynomial, that means we're looking at to the 5th power, because that would be the next thing, which if you type all that in your calculator is 8.1 times 10 to the negative 5. Okay, what is the minimum number of terms of the Taylor series centered at 2, necessary to approximate 2.3 with an error of less than 0.01. Okay. Our nth derivative now is less than 2. I'm going to do this in a chart. My error for this one is going to be less than 2.3 minus 2 to the n plus 1 over n plus 1 factorial. Okay, there's a difference between degrees and terms, okay? And you might be asked for the degree, you might be asked for the terms. So I'm going to make a chart, and you can do this however you want. Okay, if I have one term, the degree is going to be a 0. Because it would just be a constant there. So the error is going to be 2 times 0.3 to the 1, because we'll add 1 to the degree, over 1 factorial, which is 0.6. If we have two terms, that means we have a linear function, so the degree is 1. So my error is going to be 2 times 0.3 squared over 2, which gives us 0.09, which is still bigger. So we can probably predict this will be the right answer. If we have 3 terms, that means my degree is 2. We've got the constant, the linear term, and the quadratic term. So the next term would be 0.3 cubed over 3, which gives me 0.0 factorial over 0.009, which is less than 0.001, which means we want 3 terms. Okay, if we were asked for the degree, it would be the second degree. Okay, this last one has also been eliminated from the test, so you can give it a try, but it is not on the test, so we're going to stop here.